Okay, Algebra 1, on your assignment today, you're going to be working with inequalities and graphing them. And the very first thing you're going to need to do is to determine which of a set of coordinate points, which ones are solutions to the inequality. So you're going to be given an inequality and then three coordinate pairs, and you're just going to be plugging those in for x and y and then figuring out if it gives you a true statement. If it gives you a true statement, then it's a solution to the inequality. So with -2, 4, I'm going to plug in my 4 for my y and then the -2 for the x. So it would look like that. Then I have, that's still 4, -3 times -2 is 6, and 6 plus 4 gives me 10. And then I look at the inequality I have left, and it says 4 is less than or equal to 10. Since 4 is less than 10, this is a true statement, which makes this point a solution to the inequality. So I'm going to start over with the 1 and 7. And see if that is a solution to the inequality. So if y is 7, put 7 there, less than or equal to, and then -3 times -1 plus 4, and then -3 times -1 is 3, 3 plus 4 is 7, so I have 7 is less than or equal to 7, and since 7 is equal to 7, and that's that's a possibility, then this here is a solution to the equation. Now, if you get it like this and you end up with something like, say, 7 is less than 7, and it doesn't have the or equal to, that's not true, because 7 can't be less than 7. But with this case, because it has that or equal to, 7 is equal to 7, and that's one of the options, and so it works. Let's try the last point to see if that's a solution. Okay. And so I'm going to plug in 4 and -3 for my x and y. So I'll put -3 right there, make that less than or equal to -3 times 4 plus 4. And -3 times 4 is -12. -12 plus 4 is -8. So I end up with -3 is less than or equal to -8. Well, since -8 is smaller than -3, this ends up being a false equation, which means that this point right here is not a solution. So of the 3 points or 3 coordinate points that I was given, I have 2 that are solutions and 1 that is not. Okay? Okay, the next thing you'll be doing is graphing the inequalities on a coordinate plane. So the first thing you're going to do is you're just going to be graphing the boundary line, and you do that by following slope-intercept form. And so this +2 is the y-intercept, so I'm going to put a dot at +2. And then I need to do the slope, which is -3 over 4, which means I'm going to go down 3 and then to the right 4. Remember, slope man always runs to the right. And then I notice that since it's just a greater than symbol, that means that my point could not be on the line, so it's going to be greater than the line. I need to show that by drawing a dashed line, connecting the dots, so it would look like this. And then it can be anything greater than that line, so I'm going to shade above the line. Okay, and you just need to shade as large as your graph is. So something like that, but you need to make sure that you can really see that dashed line. So that would be a good solution. So your graph needs to look like that, and then the next thing you're going to do is determine if you basically have done it right by choosing a test point. A good test point is always the origin, 0, 0. And since I see that if I put a dot on 0, 0, I can see that it's not in my shaded region. So if I plug in 0, 0 for y and x, I should get a false equation. So I'm going to do that just to test it. So I'm going to put 0 is greater than -3/4 times 0 plus 2. Okay, using 0, 0 is easy because this is always 0 right here. So 0 plus 2. So is 0 greater than 2? No, that is not true. That would be false, which means that that is correct. We've done that right because it should have been false since the test point was outside of the shaded area. So let's look at this one. Again, we're going to start with our y-intercept, which is going to be -1. So I'm going to put a dot on the -1, and then I'm going to go do my slope, which is 2. So I'm going to go up 2 over 1. Do that a couple of times. Okay, Now I'm going to determine what kind of line to draw, and since it's less than or equal to, then that means that it could be on the line, so I'm going to draw a solid line. And it looks like that. And since it's going to be anything less than or equal to that line, I'm going to shade below it. So I'm going to just draw my shading like that. You use your pencil and make it much neater looking than that. Okay, the next thing you want to do is choose a test point. I pretty much tell that the origin is not in the shading, but since it's kind of close, I'm going to choose the point -1, 1, that one right there. I can tell for sure that that's not in the shading. Okay, so if I did that, that means I'm doing the point -1, 1, and I can go 1 is less than or equal to 2 times -1 minus 1. Well, 2 times -1 is -2, and -2 minus 1 is -3. So that gives me this equation, 1 is less than or equal to -3. Not true, that's false, which it should have been because it was not in the shaded region. So we have done our graph correctly. That's it. That's all you're doing today. Let me know if you have any questions. Remember that greater than or less than means you need to use a dashed line for your border line or boundary line, and greater than or equal to or less than or equal to means a solid line because it could be on the line. Okay, so and then either one, the greater than, you're going to shade above the line, and the less than ones you would shade below the line. Let me know if you have any questions. I'd be happy to help you, and I'll see you guys tomorrow.